Welcome to this video on adding and subtracting radical expressions. Let's begin. In general, we can combine like terms. For example, 2x plus 3x is equal to 5x. But what if we have the expression 2x plus 3y? There's nothing we can do in this case because 2x and 3y are not like terms. We can perform similar procedures with radicals. What if we have 2 square roots of 7 plus 3 square roots of 7? Well, altogether, that means that we have 2 plus 3 square roots of 7, or we have 5 square roots of 7. Adding is just counting things, right? If you have 2 of something and I have 3 of something, together we have 5 of that thing. So 2 somethings plus 3 somethings is equal to 5 somethings. In this case, the something is just the square root of 7. What about this next expression? 2 square roots of 7 plus 3 square roots of 5. Well, in this case, the somethings are different somethings, right? If I have 2 apples and you have 3 oranges, we don't have the same kind of fruit, right? So that's all you can say. So 2 square roots of 7 plus 3 square roots of 5, they are not like terms, okay? So here they are like terms, and because they are like terms, we can combine them through addition. They're not like terms, so for the second example, so there's nothing we can do. What about 2 square roots of 7 plus x square roots of 7? Well, in this case, we would have 2 plus x times the square root of 7. Since I don't know what x is, I can't simplify this any further. Make sure you use parentheses to group the 2 and the x together. Alright, let's look at example 1. This one says 2 square roots of 18 plus 3 square roots of 50. At first inspection, it's clear that the square root of 18 and the square root of 50 are not the same. But let's see if we can do a little bit of magic and simplify it so that there are things we can combine. So remember, in the last section, we learned how to simplify square roots. So the square root of 18 is equal to the square root of 2 times 3 times 3. Remember, there's a pair of 3's in this case, so we can rewrite the square root of 18 as 3 times the square root of 2. Likewise, if we look at the square root of 50, well, 50 is 2 times 25, and of course, 25 is a perfect square. So we can rewrite the square root of 50 as the square root of 2 times 5 times 5. So we can rewrite it as 5 times the square root of 2. So let's use that and substitute those new expressions into the example and see if we can make any headway. So 2 times the square root of 18 plus 3 times the square root of 50. So in place of the square root of 18, I'm going to write 3 square roots of 2 because we just found out that those are equivalent expressions. In place of the square root of 50, I'm going to write 5 times the square root of 2. Well, now we can just do some multiplication. So we have 6 square roots of 2 plus 15 square roots of 2. Uh-oh, what did I write square root of 6? There we go. Sorry about that. I don't know. So we have 6 times the square root of 2 plus 15 times the square root of 2. So if you have 6 of something and I have 15 of something, together we have 21 of that thing. And in this case, that thing is the square root of 2. So we have 21 square roots of 2. Alright, here's another example. So again, you can see initially it looks like none of the numbers under the radical are the same. But we're going to do what we always do, which is that we go through and do prime factorizations and figure out how we can simplify these numbers. Okay, so we can rewrite the square root of 45 as 3 square roots of 5. We already did 18, the square root of 18, but we'll do it again. So the square root of 18 is, remember 18 is 2 times 9, 9 is 3 times 3. So we have 2 times 3 times 3. We have a pair of 3's, so one of the 3's escapes. So we can rewrite this as 3 square roots of 2. Okay? Ooh, 98, that's a big number there. So this is 2 times 49, and as you can hopefully know, 49 is a perfect square. So we can rewrite the square root of 98 as the square root of 2 times the square root of 49. The square root of 49 is 7. So we can rewrite it as 7 square roots of 2. And last but not least, we have the square root of 20. So the square root of 20, well, 20 is 4 times 5, and 4 is 2 times 2. So we have 2 times 2 times 5. One of the 2's escapes, so we have 2 square roots of 5. All right, so let's take all of those values and rewrite this expression. So 5 times the square root of 45 becomes 5 times 3 square roots of 5. 6 times the square root of 18 becomes 6 times 3 square roots of 2. Then we have minus 2 times the square root of 98, but the square root of 98 becomes 7 times the square root of 2. And lastly, the square root of 20 becomes 2 times the square root of 5. So let's go ahead and do some multiplication. 5 times 3 is 15, so we have 15 times the square root of 5. 6 times 3 is 18, so we have 18 times the square root of 2. 2 times 7 is 14, so we have 14 times the square root of 2. And then we have 2 square root of 5. Okay, so let's look at this and see if we can figure out which terms can be combined. So I have a square root of 5 term here, and I have a square root of 5 term here. Okay, likewise, I have a square root of 2 term here and a square root of 2 term here. Notice I am circling the sign next to the number, which is important because I don't want to forget that sign. It goes with the number. So let's rearrange this. Let's just rewrite this so that like terms are next to each other. So I have 15 square roots of 5 plus 2 square roots of 5. Well, 15 plus 2 is 17. So we have 17 times the square root of 5. Now let's go to our square root of 2 terms, or our purple terms. So we have 18 times the square root of 2 minus 14 times the square root of 2. 18 minus 14 is 4. So we have 4 times the square root of 2. So our final answer is 17 times the square root of 5 plus 4 times the square root of 2. And that's it. All right, let's do another example. So again, we have 3 different numbers. We have 12. So 12 is 3 times 4. 4 is 2 times 2. So the square root of 12 is equal to the square root of 3 times 2 times 2. 1, 2 escapes, so we can rewrite the square root of 12 as 2 square roots of 3. Okay, if we look at 27, that is 3 times 9. 9 is 3 times 3. So the square root of 27 is the square root of 3 times 3 times 3. We have a pair of 3's. One of them escapes, so the square root of 27 is the same as the square root of 3 times, the square root of 27 is equal to 3 times the square root of 3. All right, then we have a large number here, right? We have 108, so let's divide that by 2. Well, that's 2 times 54. 54 is 6 times 9. 6 is 2 times 3. 9 is 3 times 3. So we have a lot of numbers here. So we're going to have the square root of 108 is the square root of 2 times 2 times 3 times 3 times 3. So we're looking for pairs of 2. So 1 2 escapes and 1 3 escapes. So we have 2 times 3. There's still 1 3 stuck under the radical. 2 times 3 is 6. So we have 6 square roots of 3. Okay, notice I didn't touch the x's. Since there's just a single x, he's just going to stay under there. He doesn't have a buddy to escape with. All right, so let's rewrite this expression. So instead of the square root of 12x, I'm going to write 2 times the square root of 3x. Again, the one thing that I'm kind of adding back into this part is the x, because I didn't bother with those when I was doing the work below. Okay, so the square root of 27, I can rewrite as 3 times the square root of 3, and the square root of x, he just stays there. Okay, the square root of 108, I rewrite that as 6 square roots of 3, and the square root of x stays there. All right, so let's do our multiplication. 7 times 2 is 14, so I have 14 times the square root of 3x. 4 times 3 is 12, so I have minus 12 times the square root of 3x plus 6 times the square root of 3x. So I have 14 minus 12 plus 6 all times the square root of 3x. Well, 14 minus 12 is 2. 2 plus 6 is 8. So this in total gives me 8 times the square root of 3x. And that's my final answer. All right, let's look at example 4. So we've already done the prime factorization of 27 in the previous problem, but we can do it again. So 1, 3 escapes. We get 3 times the square root of 3. 12, again, we've already done 12, but we'll do it again. So the square root of 12 is equal to the square root of 3 times 2 times 2. 1, 2 escapes, so we can rewrite that as 2 times the square root of 3. Okay, so we have 4 times, well, the square root of 27, we can rewrite that as 3 times the square root of 3. The x doesn't have a partner to escape with, so he just stays under the radical. Okay, then just bring the 8 down, rewrite the square root of 12 as 2 times the square root of 3. Again, the x just stays in there. So we do our multiplication, we get 12 times the square root of 3x. 8 times 2 is 16 times the square root of 3x. So we have 12 minus 16 times the square root of 3x. Well, 12 minus 16 is negative 4. So our final answer is negative 4 times the square root of 3x. Okay, example 5. So this one is going to be a little bit fun and interesting because now we have higher powers of x, so we'll actually be able to pull some of the x's out of our radical. So the square root of 2, can't really do anything with that. The square root of 2 is just equal to the square root of 2. What about the square root of 8? Well, 8 is 2 times 4, and 4 is 2 times 2. So we have 2 times 2 times 2. One of the 2's escapes, so we can rewrite 8 as 2 times the square root of 2. What about 72? Well, if you want, you can do the prime factorization. I'm going to take a shortcut here, just to remind you of this other method. 72 is 36 times 2, so the square root of 72 is the square root of 36 times the square root of 2. 36 is a perfect square. The square root of 36 is 6. So I can rewrite the square root of 72 as 6 square roots of 2. Okay, so that's the first step. So let's just take a minute and rewrite this just using the information we have. Okay, so x square root of 2x cubed, nothing changed there so far. We're going to do more stuff, but right now nothing's changed. Okay, I'm going to rewrite the square root of 8 as 2 square roots of 2, and then I'm going to keep the square root of x to the 5th. I'm just going to bring him down, not really messing with him yet. We will, we're just not there yet. Okay, I'm going to rewrite the square root of 72 as 6 square roots of 2, and then again just bring down the square root of x to the 3rd. Okay, all right, so we have x times the square root of 2, and let me write it like this. I think it'll help us a little bit. So x times the square root of 2 times the square root of x to the 3rd minus 3 times 2 is 6. 6 square roots of 2 times the square root of x to the 5th power. Okay, x times 6 is 6x, so we have 6x times the square root of 2 times the square root of x to the 3rd power. Okay, so the pieces that still need to be simplified are this guy, and this guy. Okay, and if you remember from a previous video, what we do is we divide the exponent 3 by the root. Remember, we're taking the square root. All of these are square roots. So 3 divided by 2 is 1, remainder 1. 5 divided by 2 is 2, remainder 1. Okay, and 3 divided by 2 is 1, remainder 1. So at this point I'm out of room, so I'm going to erase this bottom part here. Okay, so remember our pattern here is that this is the exponent of x that escapes, that's on the outside of the radical. This is the exponent of x that's on the inside of the radical. Okay, so let's see if we can rewrite this term. So we still have the x, just bring him down. Bring down the square root of 2. Instead of the square root of x cubed, I'm going to write x times the square root of x. So this first power comes here, this first power comes here. Okay, same thing with the next one. Okay, we bring down the 6, we bring down the square root of 2, we rewrite the square root of x to the 5th power as x squared times the square root of x. Okay, again, this 2 goes here, this 1 goes there. Okay, last but not least, we have plus 6x times the square root of 2, and then we are going to rewrite x to the 3rd power, just like we did in the first term. We're going to rewrite it as x times the square root of x. Okay, so this guy needs a little bit of cleaning up, right? So the first thing I'm going to do is I'm going to rewrite it just so that all of the non-radical terms or values are on one side, and then I'm going to put the radicals, the values under a single radical like that. So I'm going to rewrite this as x times the square root of 2x. Okay, x times x is x squared, so I can rewrite it like this. Okay? All right, then we have 6 times x squared, and then we still have the 2 and the x under a radical. Okay, same thing here. We have 6x times the square root of 2x. So let's see if we can simplify this. So we have minus 6x squared times the square root of 2x plus 6x squared times the square root of 2x. Okay, we're almost done. Okay, notice that these, right, the positive x squared minus 6x squared and plus 6x squared, are all like terms. We can combine them. So 1x squared minus 6x squared plus 6x squared, well, that's just 1x squared. So our final answer, after all of that work, is x squared times the square root of 2x. All right, here's another example. So this one's a little bit interesting. So take a minute, pause the video, look at this, and see if you see anything a little bit tricky. Did you notice that you have a fourth root here, and a third root there? That's a little bit mean, right? Because that's something that you might overlook, especially if you're rushed or if you're stressed out. Okay, so inside the radicals, so 3x, there's nothing really we can simplify. So which of these are like terms and which of them are not? Well, hopefully you realize that the fourth root of 3x, these are like terms that can be combined. This guy, because he's the third root, cannot be combined. He's not part of the group. Okay, so I can combine the first one. I can say 7 minus 2 times the fourth root of 3x, right? But there's nothing else I can do with third root of 3x, right? The third root of something is not the same as the fourth root of something in general, okay? So 7 minus 2 is 5, so I have 5 times the fourth root of 3x plus 2 times the third root of 3x. Okay. Also, just notice here, I don't know if you are paying attention, I try to leave a little bit of a space, and I actually put a multiplication sign here. To me, if I look at this, it's a little bit ambiguous. It's like, is it trying to tell me that 7 is being raised to the fourth power, or are we taking the fourth root of 3x? I think that the notation is kind of confusing. So if you leave a space here and put a multiplication sign here, to me, that's much more obvious that this is just a 5, no exponent, and that the 4 is actually the fourth root of 3x. Same thing here. 2 doesn't have an exponent. It's 2 times, and this 3 is the cubed root. It is not an exponent for the 2. Okay, let's look at this last example. So the only number that we need to simplify under a radical is the square root of 4. And of course, the square root of 4 is just 2. So I'm going to rewrite this as 2 times the square root of 7 times the square root of 5 plus 9x squared times the square root of x cubed times the square root of y to the 5th minus 5xy times the square root of x to the 5th times the square root of y to the 3rd. Okay, so when I do the square root of x to the 7th, remember what I need to do is I need to divide 7 by 2. So remember, you can use long division. 2 goes into 7 3 times. 3 times 2 is 6. 7 minus 6 is 1. So I have 3, remainder 1. So that means I'm going to rewrite the square root of x to the 7th as x to the 3rd times the square root of x. Because remember, the first number is the exponent of the variable on the outside. The second number, the 1, is the exponent of the variable on the inside. Okay, so we're going to do the same thing with y to the 5th, the square root of y to the 5th. So this is going to become y squared times the square root of y. And if you're wondering how I got that, I did 5 divided by 2, which is 2, remainder 1. Okay, let's keep going. So the square root of x cubed, well, 3 divided by 2 is 1, remainder 1. So this is going to be x times the square root of x. And we already did y to the 5th. We know that that is y squared times the square root of y. So then we have minus 5xy. We already did the square root of x to the 5th. Well, we did the square root of y to the 5th. Same thing. So we have x squared times the square root of x. And then we have y square roots of y. Okay? So if that is unfamiliar to you or confusing, please go back and watch some of the previous videos where I take much more time with that process. Okay, so let's rewrite this. So I have 2x to the third y squared times the square root of xy plus 9x, well, let's see, we have x squared times x. Let's evaluate that. So remember, x squared times x, we have to add the exponents. So that's going to be x to the third. And then we have a y squared times the square root of xy minus, again, we have an x times an x squared. We add those exponents to give us x to the third. So we have 5x to the third y. Uh-oh, we have y 1, 2, so it looks like we have y squared. And then we still have the square root of xy. Okay, so let's stand back and see if we really have some like terms. Remember, to be like terms, things, they have to have the same variables all raised to the same exponent or under the same radical. Okay, so notice that this term, and this term, they are identical. So we can just count them, right? We have 2 of them plus 9 of them minus 5 of them. Okay, so we have 2 plus 9 minus 5. Well, 2 plus 9 is 11. 11 minus 5 is 6. Okay, so we're going to have 6 times x cubed y squared times the square root of xy.